Okay, so I'll make, so this one here, I'm going to use colors instead of writing a ton because I think it'll save on space. So for this one, we'll do this table. For this domain, we'll do the middle table. And for the last domain, we'll do the last table. Okay, so we need to fill in some values so that we can accurately plot this on our grid. So I'm going to draw out a quick little set of axes, okay, with our x-axis and our y-axis. So when we have a domain that has two numbers in it, we want to include both of those numbers. So I'm going to include -1 for sure. And I'm going to put next to it that I have an open dot there because it's strictly less than. And I also want to have -6 in there, but this one's going to have a closed dot because it's less than or equal to. What questions do you guys have about that so far? Okay, and I want to put maybe 2 more points in there. I'm going to do -2 and -3, I guess. Okay, so we'll find all the values for those. This was the absolute value function, so these should be easy values to find. Let's see, who have I not called on? Shayla, are you there?
Yes.
Okay, so Shayla, we're sticking each of these values into this absolute value of x function. Can you tell me what the result will be for each of them? So what's the absolute value of -1?
I don't know.
So what does absolute value do? That function do? If I stick a number in there, what does it do to it?
I don't know.
Okay, so absolute value is going to take any number, and if it's negative, it's going to spit out the same thing but positive. If it's positive, it just spits out the same thing. Okay, so it's just taking a number and making it positive. So it's going to take -1 and turn it into +1. So what is it going to do to -2?
2.
Yep. And -3?
3.
Yep. And -6?
6.
Perfect. Thank you very much.
Mm-hmm.
All right. So we've got those there. And I'm going to go ahead and plot them. So we have negative values here, -1, 2, 3, 4, 5, and 6. Okay. So this is -1, -2, -3. Okay. And then we have positive values going up there. So 1, 2, 3, 4, 5, and 6. Okay, so I'm going to put a point at -1, +1, but it needs to be an open circle. Okay, because that's what I marked on my thing because we do not include -1. Then we're going to go -2, 2, -3, 3, -4, 4, -5, 5, and -6, 6. So we should get, and we have a closed circle there because that's where our domain ends. So we should get this line going through those 2 points. Okay, so this is the blue section of our graph. Okay, what questions do you guys have so far? Okay, there are no questions. We'll go ahead and do the next one. So again, here we have -1 and +1. We want to include both of those values in our table. So -1 and +1 definitely need to both be in there. The -1 is going to have a closed dot because we have a less than or equal to sign next to it. The positive one has just a less than sign, so we need an open dot right there. Okay, and the only integer actually between -1 and 1 is 0. So I'm going to put 0 right here. Okay, so now I need somebody to fill in the right-hand side. We're sticking -1, 0, and 1 into this x squared function. So let's see. Matthew, can you fill in that table for me?
Yes.
Okay, so what's -1 squared?
1,
What about 0?
0,
And 1.
1.
Perfect. Thank you very much, Matthew. So now I am going to plot this on my graph. So I need a point at -1, +1. So this actually overlaps right here. Then I need a point at 0, 0, and then a point at 1, 1. So we have this little piece of the quadratic right here. Oops. And at -1, 1, I should have an open dot. Or at +1, 1. I'm sorry. Okay, but this one closes off because this one includes it. All right, the very last one is the pink one. We only have one number we need to make sure we include, which is that +1, and it's going to have an open circle there. And we want numbers bigger than 1, so I'm going to add 2 and 3. Okay, so this function right here is what we're subbing things into. So let's see who's next. Betsy, can you help me out?
Yes.
Okay, so this is the constant function 4. So what should I get no matter what number I put in? Is there like a place to put these numbers in at all?
No.
No. So I have to pick this number. So what should I put next to each one of these?
4.
Yeah. So when I put 1 in, I get 4. 2 in, I get 4. 3 in, I get 4. Thank you. So I'm going to put an open circle at 1, 1, 2, 3, 4. And then at 2, I'll have a point. At 3, I'll have a point. And it would go all the way out. This one says all the x values bigger than 1, so we're going to have an arrow here. Okay, so we didn't have an arrow over here because we stopped at -6. But on this one, it says all the x values bigger than 1, so we do have an arrow. So this is what our piecewise function should look like. Let me color so that you guys can see each piece. Oops. All right. And that's what we should have. What questions do you guys have about that?
Wait, Ms. Roberts, why did you write the arrow again?
Because these are all x values bigger than 1. So it's going to go like to infinity. That was a good question. Anything else?
How do you figure out what the graph, the numbers by just looking at the graph, if that makes sense?
That's a really good question, actually. Let's try that. So let's make up something. So maybe f of -3, we'll do 2 times f of -3 plus f of 0 minus f of 4. Okay, so maybe I ask you to evaluate something like this. That was like a problem like on your last homework and classwork assignments. So what I would do is I would look at f of -3. Okay, this means I want to find where -3 is on my x-axis. And I would want to scroll up until I hit the function and then map over to see what I got. Okay, when I do this on this, what number did I get? Who asked that question? I'm sorry.
Isai.
So if I go up from -3 and then map over to y, what number do I get?
3.
Yeah, so that's going to be what I replace f of -3 with. So I get 2 times 3 instead of 2 times f of -3. All right, then f of 0, if I look at the x value 0, what's my y value, Isai?
0.
Yep, so I'm going to have plus 0. And if I went out to 4, what would my y value be?
4.
Yeah, -4. So I would end up with 2 times 3, which is 6, minus 4 to give me a total of 2. And that would be my final answer. Does that help?
Yeah, thank you.
Yeah, you're welcome. What other questions do you guys have about that? That was a really great question. So when you have problems like that, you're just looking for the number on the x-axis. So the number inside the parentheses, you find on the x-axis, you map it up to the function, you map it over to the y value, and that y value is what you're replacing the entire f of whatever value with. Okay. Okay. Any last questions on this particular function? Okay, if there are no questions, I want to go through the around the world assignment that I have assigned for you guys today. Okay, so I believe I posted an answer sheet, but if you do not have a printer, it's totally fine for you just to make your own version of that answer sheet. And I know that I did this for my other class. So let me find, here we go. So this is the around the world piecewise functions, okay? So I literally made my own answer sheet on notebook paper, okay? So there are 11 total problems. So I did 6 problems to a page. So I would do 6 on the front and then, is that what I did? Yeah, and then 6 on the back and then just like cancel out 1. Okay, so there are 11 total problems and they should look like they're on cards like this that are uploaded in Canvas. Okay, let me see, hold on one second. Let me see if I can make the lighting better. Okay, maybe this will work a little bit better. Yeah, that's a little better. Okay. So each problem, so like you'll have a number 1. You're going to look at this piecewise function. The problem is above the line, okay? So the graphs are the answers. So you're going to look at number 1, okay? And we did this together with my other class. And let me zoom in a little bit there. I'm just going to see if I can make this any darker. Oh my goodness, there it is. Oh, look, I can. Hey, that's much better. Okay, perfect. All right. So, these are like kind of the problems. Okay, it's going to give you a piecewise function. What I want you to do is, excuse me, identify which graph belongs with that piecewise function. Okay, so what I did is I kind of sketched out the graph as my work. Okay. And then I looked through these cards and I looked at the graphs at the bottom. So A didn't match, B didn't match. I went all the way through until I got to I, J, K. And I found that, oh my goodness, I wish you could see all of these things. Maybe I can zoom out even more. I found that the graph that I made looked pretty similar to the graph on this paper, okay? And I found that it was actually exactly the same. When I plotted points from my original problem, okay, so this was number